Hey, welcome on to Hands on Chemistry with me, Mr. Hands.
You've already considered chemical changes. You've looked at combustion, oxidation, neutralisation, exothermic, endothermic reactions, displacement reactions and thermal decomposition. But in some reactions, the reactants don't always go just to products. The products can also react to produce the original reactants. A couple of examples you must know. Hydrated copper sulfate, which is blue, when heated, gives off water and produces anhydrous copper sulfate, which is white. If you add the water to anhydrous copper sulfate, it produces blue copper sulfate, hydrated again. Another example is ammonium chloride. Ammonium chloride is a white powder, but it can break down to form ammonia and hydrochloric acid, from which it's formed from. If a reaction is exothermic in one direction, it's endothermic in the other, and the amount of energy given out or taken in is the same. So we already know what a reversible reaction is. It's where the reactants can become products and the products can change back into reactants. Now, in a reversible reaction in a closed system where nothing can be added or removed, the rate of the forward and reverse reactions are equal, and the concentration of reactants and products is constant. Now, the concentration of the reactant and products can be changed by changing the reaction conditions. That's like by adding more reactant or removing some of the product, by changing the temperature or increasing or decreasing the pressure. Now, Le Chatelier's principle states that a system at equilibrium, a closed system with equal rate and constant concentrations, will oppose any change applied to it by counteracting the change. So increasing the temperature, the equilibrium will reduce it. Increasing the pressure, equilibrium will reduce it. What is the effect of changing concentration and pressure on equilibrium? Well, if the concentration of a reactant or product is changed, it's no longer equilibrium until a new one is reached. If the concentration of reactant is increased, more product will be formed until equilibrium is reached again. If the concentration of the product is decreased, more product will be formed until equilibrium is reached again. By changing the pressure, Le Chatelier says the system at equilibrium will oppose the change applied to it by counteracting it. So if the pressure on a system at equilibrium is increased, equilibrium shifts to the side with the fewest molecules. If the pressure on a system at equilibrium is decreased, equilibrium shifts to the side with the largest number of molecules. The effect of changing temperature on equilibrium depends on the reaction. Depends if the forward reaction is exothermic or endothermic. Consider these examples. If the temperature of a system at equilibrium is increased, the relative amount of product increases in an endothermic reaction, so the relative amount of product decreases in an exothermic reaction. If the temperature of the system is decreased at equilibrium, the relative amount of product increases in an exothermic reaction. The relative amount of product decreases in an endothermic reaction. Consider the Haber process, where 3 molecules of hydrogen react with 1 molecule of nitrogen to produce 2 molecules of ammonia. The reaction is exothermic, so increasing the temperature will reduce the amount of product.
Watching, if you've enjoyed this video, then why not subscribe?